Therefore, what is going to be our cos alpha?
Cos alpha will be 12 over 18.
Correct. So it'll just be 12 all over 13, right? So you have this over here. But you want, of course, you wanted to make it look neat. Now, if you have something, if you have a fraction in your denominator, in order to bring it to the the upper part, you can just treat it now as a multiplication, because you see, and now it's a division, but once you bring it to the top, it will be a multiplication. And once you bring it to the top and as a multiplication, this numerator and the denominator, they will swap, right? So now you're going to have 12 all over 5 multiplied by 13 divided by 12. And what are you realizing? You have what? Like terms over here. And they can just sommer cancel one another. They are going to cancel one another because they are the same and opposite. Right. But if they were both in the numerator, they can't. If this 12 was in the numerator, they were not going to cancel one another. And guys, so you'll be left with 13 all over 5. Because eventually, when from this step, from this step, this one, you are going to have 1 all over 5 multiplied by 13 divided by 1. When you multiply these two together, you get this answer over here. Is that what you guys got?
Ma'am, can I ask, when multiplying fractions, is it like how you, is it like a butterfly, or like you multiply across?
It's across. It's numerator to numerator, denominator to denominator.
Okay.
Yeah. Is this what everybody got?
No.
What did you get for your answer?
I didn't get my final answer because I wasn't done. I thought maybe with the at the 10 beta you do that part of identities where you would say sine beta over cos beta. And then
Sine,
from there I was just confused.
sine beta all over cos beta. Actually, let's try doing it that way. So you'd have, oh, it would be, it's going to, I think eventually you have to arrive here, but it's going to be long and tedious, right? Because you're
Yes,
going
ma'am.
to have, let's just start here. You're going to have sine beta divided by cos beta, all divided by what? All divided by cos alpha, right? So, firstly, you could work this out by taking it to the numerator already. So you're going to have, because remember, you are dividing by this. So if you take it to the numerator, it's going to be easy. It's currently in the denominator, but once you take it up, it will be in the numerator. So you'll be left with sine beta all over cos beta multiplied by cos of alpha. Right? Let's just see how it's going to work out. And then what is sine beta? So opposite over hypotenuse. So it's going to be 12 all over 13. All divided by what? What is cos of beta? Adjacent over hypotenuse. So it's going to be 5 divided by, what is this? This is 5 divided by 13, right? All multiplied by, what is cos alpha? Adjacent over hypotenuse. This is 12 over 13. 12 all over 13. Now we're going to try and bring this way to the numerator. And once we bring it here as a multiplication, we have to swap them, right? So we'll have equals to 12 divided by 13 multiplied by 13 divided by 5 multiplied by 12 divided by 13. This and this will take care of one another. Wait, to be adjacent over hypotenuse. Adjacent over hypotenuse. What did I do wrong? What did I do wrong? What did I do wrong? Sine. So opposite over hypotenuse, correct. Cos adjacent over hypotenuse. Wait. I did this the wrong way. Because it's adjacent. Remember, wait, it's cos of beta, man. Yeah, it's adjacent over. No, this is correct. Sorry. 15 divided by 13. All multiplied by cos of alpha. Adjacent over. It's going to be 12 divided by 13. 12 divided by 13. You bring this up, it will be. This is correct. And you take this. Yes, this will be correct. Multiplied by. No. Yeah, it wouldn't work this way because we're not getting the same answer as. Did somebody do it like this again also and get a different answer besides this one? Like get this answer, the one that we got over here. This one, sorry, because it's supposed to give us a 13 divided by 5. Okay, wait. I think, yeah, I can see where the mistake is. Remember, if we have, sorry, nah, if we have sine beta divided by cos beta multiplied by cos alpha, we could, initially it was written as this. Initially it was written as this, ne? Let's try just working it out immediately from this point, right? Because we know what is sine beta, it's just 12 divided by 13, all divided by um cos beta, which is adjacent over hypotenuse. It's just 5 all over 13, all divided by cos of alpha, which is adjacent over hypotenuse, which is just 12 all over 13. Yes, I think this is where we went wrong over here. So now, first things first, you're going to want to take this one way upward, right? So from this point onward, note this, you'll have, can you guys still see my screen?
Yes, ma'am.
So from here, you will have 12 divided by 13, all divided by 5 divided by 13, multiplied by what? Now, when you take it to the numerator, they will swap, right? So you'll have multiplied by 13 all over 12. Now you're not done. You have to take this one also to the numerator. So you'll have 12 divided by 13, multiplied by 13, divided by 5, multiplied by 13, divided by 12. I think now this is a 13, this is a 13, this is a 12, this is a 12. So yeah, 13 divided by 5, which is correct because it looks exactly the same as this one. So yeah, it does work out, but you should be careful not to do this mistake that we made over here, right? Take it exactly as it is, like this, and then work them out one by one. Ne?
Yes, ma'am.
Okay. Yeah, so we're done with number 1. 3.2. So how did you go through 3.2? Let me rewrite the question on 3.2. So they're saying simplify, right? Simplify what? Simplify sine of 180 plus x multiplied by cos 90 minus x squared plus sine of a negative x multiplied by cos squared 180 minus x. So how did you go about this one? Okay, Lisa, how did you go about this one?
Sorry, I stepped out for a moment. Can you ask the question again?
Oh, I was saying, how did you go about this question? 3.2.
3.2. First, I started off by, you see, what I did was I looked at the graph and I saw if I could plus or add anything to any of the other ones to make it a bit easier for myself. I just applied the trig rules.
Mm-hmm.
So then with sine plus 1 plus x, 180 plus x, I said minus sine x, because then that's the simplest form afterwards, right?
Mm-hmm.
And then with the cos to the power of 290 minus x, it's sine to the power of 2x.
Which one? This one is going
Yeah.
to be sine to the power of 2x. Yeah?
And then I said minus sine x,
Minus sine x. Okay.
and then here it's minus cos to the power of 2x.
Minus. Minus. Minus what? Cos to the power 2x.
Yes.
Okay. Yeah, you are correct, ne? You're very correct. Like, okay. Now let's explain why she did what she did. Right. So for the first one, which is this term over here, if they're saying simplify, right? We know using our cast diagram, we have 90 minus x over here, 180 minus x, 180 plus x, 360 minus x, right? And now, when they say sine 180 plus x, we have to go to this quadrant where we have 180 plus x and see what's the behavior of sine in that quadrant, right? So where is 180 plus x? Here it is in the third quadrant, right? So we can see because of our cast, tangent is the one that's positive here. So it means everything else that's not tangent, what would it be? It'll be a negative, right? Hence, here she said it's going to be negative sine x. So we will have minus sine x. Is everybody on board with this one? Hey guys, do you guys get it?
Yes, ma'am.
Okay. So fine. Now let's move on to the next one. This is what we call complementary angles, right? Um, we have four of them, right? We have cos 90 minus x being equals to what? Sine x. We have cos 90 plus x equals to, is this the one that changes the sign? Somebody say yes. Now, is the cos 90? I think the cos 90 is the one. Yeah. Yes. Sine x. And then we have sine 90 plus x equals to cos x. And we have sine 90 minus x equals to cos x still. So these are what we call complementary angles, right? We add both of them, we get a 90-degree angle. So when you see 90 minus x, just always think 90 minus x or 90 plus x. Just always think complementary angles. And the only one that's different here, it's the cos 90 plus. Let me just confirm, guys. Let me just confirm before I start feeding you guys all this information. Yes, cos 90 minus x, it's sine x. Or cos 90 plus x, which is this. Yes. And reason why, so that we don't cram it or anything. Reason why not cos 90 plus x is a negative sign, right? Let's go to the 90 plus x quadrant. This is the 90 plus x quadrant, right? Remember. And we're saying cos of 90 plus x. Before anything and everything, you have to account for the behavior of cos at that angle. So cos in this angle, it's negative, but we know for a fact that its complementary angle, what is it? Its complementary function, what is it going to be? It's going to be sine x. But we have to account for the fact that cos was negative in that quadrant. It's the only one that's negative in that quadrant, if you can actually check. Because if you say cos 90 minus x, it's here. They're all positive. If you say sine 90 plus x, it's here. Sine is positive here, so our cos is going to be positive. If you say sine 90 minus x, it's here. Our sine is positive. So you see where the cos 90 plus x equals to negative sine x is coming from. It's on the second last page of the notes that I sent on the group. Ne? Yeah. So we will have, but because they didn't just say cos 90 minus, had it just been like this, then our answer would have been sine x. But because they said cos squared 90 minus x, we will have multiplied by sine squared x. Right? And then we have a negative angle multiplied by our sine. So we'll have negative sine x. And then here again, we have a 90 minus x thing. So we have to check at this quadrant, how is our cos behavior? It's 90 minus x. So this is the second quadrant. Sine is the only one that's positive there, right? So we're going to say it's going to be negative cos squared x. And then you're actually done. I don't know why and how is this 6 marks. Okay, no, you're not done. Okay, so okay, so from here, actually, you're going to say, because we're all here, right? What we have, it's just, I'm going to make it look proper, right? We have negative sine of x multiplied by sine x, all bracket squared, minus sine of x minus cos, cos of x close, sorry, close bracket squared. Sorry about this. Then from this, we can see that from both functions, we have a common factor. We have a common factor of what? Of negative sign. So we can take the negative sign what? Outside the bracket. Right? So we're going to have, because this is a negative sign, it's multiplied by our sine squared. And we have a negative sign being multiplied by our um, negative cos squared. You see it there? So we're going to have negative sine x all into what? If we take negative sine x from this, we're left with the sine squared. Because if we say sine squared multiplied by negative sine, we will have this term over here, the second last one, right? So from the first term, we are left with sine squared x, sine squared x. All right, and now from the second term, what are we left with? From the second term, if you take out the negative, um, if you take out the negative sine x, if you take out the negative sine x, right, you are going to be left with this cos x squared. Do you guys see that? Hey guys, do you see that?
Ma'am,
Yes.
can you please move your book like a bit to the left? Yeah.
Is this okay?
Yes,
Okay.
ma'am.
So I was saying, if we remove negative sine x from the second term, we are going to be left with plus cos x squared. Do we agree with that? Because if we have, let me do this. If we have plus cos squared x over here, right? Cos squared x. And then we multiply with this negative sine x. Eventually, we're going to have negative sine x. Remove this. Multiplied by cos x squared. Do you guys see that? Or rather, it'll be a negative and it'll be like this. So this negative is going to multiply here, and this negative is also going to multiply here. Do you see where the plus cos is coming from? Because if you multiply a positive and a negative, it will give you a negative. Do you guys get it? Do you guys get it, or should I like repeat from here?
Please do repeat, ma'am.
Okay. So what we're saying, this part, are you okay with this part though? The first part. Okay, so are you okay with this part, the first part?
Yes, ma'am.
Okay. So from the first part we have negative. Let's rewrite it in a proper way, right? We have bracket negative sine x all into sine x squared, right? And now into the second part, we'll have plus negative sine x close bracket. What? Negative cos x, sorry, squared. And I'm saying from these two things, we can see that we have a common factor in between them that we can factor out, right? So if we factor out negative sine x from the first term, we're left with sine x squared, right? So which is just sine squared x. Now, if we factor out negative sine x from this, we will be left with positive cos x. Reason why it's being positive cos x squared is because if you take this negative sine x and you multiply it, let's just be practical. If you take this negative sine x and you multiply it with this, it's eventually going to give you negative sine x cos um cos x cos squared x, which is what you have over here. Do you guys see it?
Yes, ma'am.
Okay. So now over here you'll have sine squared x plus cos squared x. Let me just erase this. So in this question, you'll now have sine squared x plus cos squared x. And remember, sine squared x plus cos squared x, according to our identities, this is just equals to 1. Right? So we can replace this by just writing 1. So we'll have equals to negative sine x all into 1. So this will be our answer. Right? Let's do another question. But this one we'll do it together because we don't have time. Wait. Wait a minute. Wait a minute. Okay. Mm. Okay, I just sent another question to group. Can we all go to it so we can do it? So we're given cos 100 multiplied by cos 315 multiplied by 10, 210, all divided by sine 675 multiplied by cos 150 multiplied by sine 170. Okay, so if you have this over here and they're saying evaluate without the use of a calculator, the thing that you're trying to do, wait, wait a minute. Okay, so if you have angles like this, right, and they're telling us to evaluate without a calculator, inside here, we have to do the method of reduction in order to get the simplified term, right? And in order to like be able to know how exactly to go about your method of reduction, remember, let's say for example, this costs 100, right? You just need to look where exactly could the cost 100 be located. Because remember, this is the 90 minus x quadrant, and this is the 180 minus x quadrant. This is the 180 plus x quadrant. This is the 360 minus x quadrant, right? So if you're
Man,
looking at, yeah. Oh, sorry.
I'm not sure if it's only me, but oh, okay. Your
It's
screen was
okay now.
frozen.
Yeah.
Yeah, it's fine.
Sorry. So I was saying, if you have something like this and they're telling you that you should evaluate, right? You normally just need to check the angle that you're given and see where it's coming from. This one will get to it, right? But these ones, the ones that exist within your Cartesian plane, you have to reduce them. Do the method of reduction, right? And let's say, for example, you take your 100. This is 0, 90, 180, 270, 360, right? Wait, did they? Mm, okay, okay, fine. This 100, it's your angle that you're given, but you're trying to find it in its most simplest form. And the way in which you can do it is by using these things, right? Okay, fine, cool. Let's take our 100. Where is the 100 located? The 100 is greater than 90, but it's less than 180. So it could be somewhere over here. Wait, let me write our cast again. So It could be somewhere over in this quadrant. What's happening in this quadrant? In this quadrant, we're being told that the operations that are done here, it's 180 minus x. And as of current, the x that we're given, it's 100. So we're now going to have, okay, let me just say cos 180 minus 100. Because this 180 minus thing, minus 100, it's our reference angle. We are referencing this quadrant because that is where our 100 is coming from, right? So from here, and another thing, when you're reducing, as much as you're just focusing on the reducing part of it, you need to check because they're saying cos at the 180 minus x quadrant. What is the behavior of cos at the 180 minus x quadrant? It's negative because that's the quadrant whereby sine it's positive, right? So we're going to have a minus cos 180 minus 100. Fine. Then now you say multiplied by, right? And now we look at 315. 315, it's greater than 270, but it's less than 360. So for a fact, it exists somewhere here, right? So now you're going to have cos 360 minus 315. Right? Again, try and look at the behavior of cos in this quadrant. Fortunately enough, it's the quadrant whereby cos it's a positive. Do you see that? Do you guys see that? Like, do you guys understand this and this?
Yes, ma'am.
Okay. Now we're saying multiplied by a 210. Fine. You come here. You come here. 210, it's probably going to be located somewhere over here. Right? So now see how this is the 180 plus x. So we must have added something to 180 in order to get our 200. So in order to try and see what was added to the 200 to get what was added to the 180 to get the 210, you can just say 210 minus 180, and this will give you 30 degrees. So which means over here, what do we have? We're going to have multiplied by 10, what? 180 plus 30, 180 degrees, uh, la, 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 plus 30 degrees, right? And then again, look at the behavior of 10 at this angle. Fortunate enough, this is where 10 is positive. Now we say all divided by. So whenever you have angles greater than 360, like your 500s, your 600s, and everything, you need to say this number that we're given, right? Um, we're currently given 675. You need to keep reducing it by 360. The reason why you're reducing it by 360, like subtracting 360 from it, is because you're trying to take this point back into the Cartesian plane, right? So when you say 675 minus 360, you'll have 5, you'll have 1, and you'll have 3. Now, see, if you say 675 minus 360, we have 315. Now, this 315 is indeed something that we can work with, right? So over here, for precision point, let's just say cos of 315 multiplied by, we'll come back to it again and reduce it properly. Or should I rather just do it flat? Okay, fine. So you know now you have cos 315 instead of cos 675. So the only trick that you needed to know was that whenever the angle is greater than 360, subtract by 360 to try and get it back. And maybe let's say you subtract once and it doesn't work. You have to subtract again 360. If it doesn't work, subtract again. So let's say you were given 1,800. You're going to say minus 360. You'll never be given such an absurd number. But I'm just trying to show that you have to say minus 360 if the answer is not within the Cartesian plane, like from 0 to 360. Again, subtract by 360, right? So now we get 315. Where is 315? Between 270 and 360, right? And we are pleased with this cost 315 because we know in order to get 315, because remember this is the 360 minus x, we just said 360 minus 45 degrees, right? And then you can erase this and write it properly as cos 360 minus 45. Again, let's look at the behavior. Sorry, ne? Let's look at the behavior of cos here. It's a positive, so we leave it alone. Multiplied by cos 150. Now, if you look at this cos 150, where are you going to find it? You're going to find it somewhere here. It's going to be given to you by cos multiplied by 180 minus 30. Right? And in this
Wait, man.
quadrant, yes,
The first cos there at the denominator. Wait, how did you get it? Not that one. Get it 60 minus 45.
which one? This one.
Mm-mm. The one that says minus 45.
This one.
Yeah, yes.
Remember, for this one initially. Oh yeah, sorry. It's a sign. I made a mistake. It's sign in it.
Yes, ma'am.
Okay. Was that your rectification? You wanted me to fix that?
Yeah, I wasn't sure where you got it from.
Yeah,
I
it's
just
actually
wanted to
supposed.
know.
It's supposed to be sign. What was it? Was it one? Yeah, it was. Was it 180 or was it? What is it? No, it
360.
was supposed to 360. Yeah, 360 minus 45, not plus, ne? Minus 45.
Yeah.
Okay. And then we have 180 minus 30 degrees, and it's this quadrant again. And what's happening at this quadrant? Cos is negative. Multiplied by sine 170. Again, we're back at this quadrant. So it will just be given to us by sine 180 degrees minus 10. Right? Okay, wait. I made a mistake. Sorry. 180 minus 10. Okay, wait. Uh, Wait a minute. Uh, yes. Mm, yes. Okay, let's just rewrite this one, the last one. All right, the sine 181. Rewrite it as sine 180 minus 170, right? Because it's supposed to be the angle minus the one that you're currently given, right? So now when we go to the third step, right, you're going to say equals to. Now we have negative cos. If you just say 180 minus 100, you're going to have 80 degrees multiplied by cos. What is this? What is 365 minus 315? It's going to give us 45, right? Yes, it will give us 45 multiplied by, yes, all over here. All over here, we're supposed to now have 10 of 30. 10, 30 degrees, right? all divided by, when we come to the denominator, we have sine 360 minus 45, which is giving us that 315 that we had. So we just really have sine of 45 degrees multiplied by I think I made a mistake over here. Not a mistake necessarily, but I started doing it the other way compared to how we are doing it. Okay, let me just erase here. Ne? I'll show you what I mean. Over here, you have negative cos. You're supposed to say, why do I have a negative here? You're supposed to say open bracket 180 minus this angle over here, the angle that we have, ne? So it's supposed to be 180 minus 150. And that's how we're going to get our negative cos of 30 degrees, right? Multiplied by, so this sign over here, it's supposed to be sine. Either way, guys, the way you reduce it, it's supposed to make sense to you and the person that's marking your paper, because eventually you have to get here. So if this step gets you here, then you're correct. Do you get it? So the last sign, you can just, yeah, sorry. The last sign, because it was sine 180 minus 70. We had 170 over here. You can just write it as 170 minus 170, which is just going to give you multiplied by sine of 10 degrees, right? Now, what I want us to denote from this is that over here, angles like 45, angles like 30, angles like 30, angles like 45. They are what we call special angles. So we have two triangles. If you go on your notes, they're there. If I'm not lying, but they should be there. That's grade 11. Wait, did I send the patterns and things? Notes. Yeah, I did send the trigonometry notes just now. There should be like the special angle triangle somewhere. Yeah, I just reacted to it now. You guys can go and view it on the group. But our special angle triangle, it's just two triangles like this, right? We have one way it's 60 and 30, and we have one way it's just, and they're all 45-degree angle. Just ignore the fact that this one looks funny. One it's 60 and one it's 30. In order to know how to do these things, like know these two triangles off by heart. Well, the 45 one, it's easy to cram because it's just 45 and a 45 over here. And you have one. The only side that where like from where the 90-degree is, like opposite to the 90 degrees, it's root 2. But the other one, which is this one, you'd have to draw it like a lot of times in order to know that, okay, it's just 1, 2, root 3. Right? So now from our previous question, what we currently have, it's, wait. Okay, what we currently have from our previous question, all over here, we have negative cos multiplied by, okay, this thing, it's negative cos 80 degrees multiplied by cos 45 multiplied by 1030, all divided by what? All divided by sine 45 multiplied by negative cos 30 multiplied by sine 10, multiplied by sine 10. And because these ones, the ones where with special angles, we can just actually derive them from the two triangles. Wait, we can just derive them from the two triangles. So over here, we're going to have negative cos of 80 multiplied by, you go to the 45 degrees angle. What is your cos? It's just adjacent over hypotenuse. So what is it going to be? It's going to be 1 over root 2, right? Cos of 45. It's just going to be 1 over root 2. 1 divided by root 2 multiplied by 10 of 30. You just go to the 30-degree triangle. What is your 10 going to be? It's going to be opposite all over hypotenuse. So it's opposite 1 all over hypotenuse, which is your 2. Am I telling the truth? Yes, I am. All divided by, sorry, that's a division. What is sine of 45? You go to your 45-degree angle again. So sine, it's just opposite, which is root 2. Wait, I'm lying. It's just opposite, which is 1 divided by root 2. So it'll be 1 divided by root 2 minus multiplied by cos of 30. You go to the 30, it's cos, it's adjacent, which is root 3 divided by 2. So it will be root 3 divided by 2 multiplied by sine of 10. So far, do you guys get it?
Yes, ma'am.
Okay.
Ma'am, do you think there's like an easy way of remembering the special
Trying.
triangles?
Easy way. I really wouldn't be. I genuinely do not think so. I really genuinely do not think so. To be honest, I don't want to lie to you. Okay, now I want us to look at the, like, I'll just check if there's like a way in which we can memorize them. I'll look at like for videos and everything. Then if I find it, I'll send it to the group. Ne?
Yes, ma'am.
Now let's look at the signs in the first in the numerator. We have a negative multiplied by a positive and a positive, right? So which means we have something that's going to be a negative. And then in the denominator, we have a negative, wait, uh negative. This angle, the two. This is supposed to be a negative because this 170, it's in the 180 plus x quadrant, right? And we didn't put the negative over here. Do you see what I'm talking about over here? There's supposed to be a negative. Ish, guys, I'm so sorry. Like my brain is so foggy. I don't know what's happening. But can you see that this is supposed to be negative sign? Reason being, it's in the 108 because no, I'm actually lying. It's sign 170. No, I'm lying. I'm lying. I'm lying. I'm lying. Sorry. Sorry. I thought it was 180 plus. It's not. 180 minus. And sign is positive there. Okay, so the sign here is a negative, and the sign in the denominator, it's also going to be a negative. Right? So now when we look at it now, we're going to have okay, negative. Let's just write the negative outside, right? You're going to have cos 80 multiplied by 1 root 2 multiplied by 2, right? All divided by what? If you multiply these two together, you'll just get root 3 divided by 2 root 2 multiplied by what? Multiplied by sine of what is this? Sine of 10. Can you guys see that? Guys, do you see what's happening?
We can, yeah, I see what's going on.
You guys understand what's going on, not just you can, yeah, you can tell, ne?
Yeah,
Oh, okay. Everybody else?
Yes, ma'am.
Okay, great. Mm, Twa, opposite over adjacent. Yeah, you see it. Sina, 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 Sina. Can we take it from here, ne? Let's look at what's happening. We have negative cos bracket 80 degrees multiplied by cos 45 multiplied by 10, 30 degrees, right? All divided by sine 45 minus cos 30 degrees multiplied by sine 10. This, we said it's from the special angle triangle, right? So couture. Okay. From the 45-degree angle, this is our cos. It's supposed to be adjacent over hypotenuse, which means we will have negative cos of 80 degrees multiplied by 1 over root 2. 1 all over root 2 multiplied by, this is the part that I wanted to rectify. I don't know where did I get this. But 10, 30 degrees, let's look at where 30 is. Remember what 10 is? Opposite over adjacent. So it's supposed to be 1 divided by root 3, not 1 divided by 2. I don't know what happened there. So it's supposed to be 1, because it's opposite divided by adjacent, 1 divided by root 3. All divided by sine 45. We go to the 45-degree angle. Sine its opposite over hypotenuse. So this would be 1 all over root 2, right? Then we have minus cos of 30 degrees. We're going to have k, which is adjacent over hypotenuse. So it's going to be root 3 divided by 2. So it will be root 3 divided by 2 or multiplied by sine of 10. I wanted to rectify this because this was incorrect. Like I wrote 1 over 2 instead of 1 all over root 2. Do you guys see that? Fine. Now we have cos 80 and sine 10. Remember, we said when we were looking at what do you call them again? Complementary angles, right? We said cos 90 plus x, it would give you negative sine x. Cos 90 minus x would give you sine x. And then similarly for the sines as well, sine 90 minus x is going to give you cos x. Same way, sine 90 plus x will give you cos x, right? So what I want you guys to realize is that what we mean by complementary angles is that it's really just two angles. If you add them together, they will give you 90 degrees. So if you have, wait, if you have sine 70. Its complementary angle, what do you guys think it will be?
Cos 30.
No, it's 70. It
It
needs
was
to
my
give you
bad.
90.
Sine
Yeah,
20, yeah.
it'll be cos 20, right? Because it has to be the opposite thing. So if we have sine 45, what will be its complementary angle?
Cos 45.
Cos 45, right? So now if we just have an angle and it's 30, what do you think its complementary angle will be?
60.
Correct. So do you guys notice the pattern that's happening? All these things are just adding up to become what? 90 degrees. And how you know that it's complementary angles, they are always less than 90. You can never have a cos 118 and you're like, it's going to be sine something. No, no ways. They always have to be less than 90 degrees. Same thing here. Because we want to be able to cancel either one out, right? So you could make this cos your complementary angle. So if you get the complementary function of cos 80, what is it going to give you?
The
Guys,
complementary of
of cos 80 degrees.
sine 10.
That's going to give you sine 10. Now let's say you take the complementary of sine 10. What is it going to give you?
Cos 80.
Cos 80. So you see, if we have a sine 10 over here, we can easily just cancel these two together. Or if we have a cos 80 over here, we can just cancel these two together. And that's what we want. Because this question, it said what? It said simplify without the use of a calculator. So without the use of a calculator, you need to get rid of trig functions. Because in the final answer, if you still have trig functions and they said simplify, you did not simplify. You did a lot of things, but definitely not simplify. So when it leads to the end, you should be on the lookout for your complementary angles. Yeah? So now let's make this cos sine 10. So you have over here, we'll just have negative sine 10 multiplied by 1 all over root 2 multiplied by 1 all over root 3 all divided by 1 divided by root 2 multiplied by negative root 3 all over 2 multiplied by sine of 10 degrees. So this one and this one will cancel. So what are you left with? Remember I said if you're multiplying and it's A divided by B cross C divided by D, you will really just do this. You multiply horizontally. It will be A dot C divided by B dot D. Same thing over here. We're going to have oh, 45. Adjacent over. Okay. So all over here, we're going to just have 1, because 1 times 1 is 1, root 2 multiplied by root 3, right? All divided by these two together, it's going to give us, oh, remember we had a negative over here. We had a negative. So another negative over here, if we multiply these two together, we'll have root 3 divided by 2 root 2. And now, same thing, we want this one to go to the top so that it can be a multiplication. Because, I mean, if it looks this way, it's just weird. So you'll have equals to negative 1 all over root 2 root 3 multiplied by this root 3 will go to the denominator. So here you'll have 2 root 2 divided by what? Divided by root 3. Am I telling the truth? Yes, I am telling the truth. And then these two will cancel one another out because they're the same. Right. And now, if you multiply a root a multiplied by root a, these roots will cancel and you'll just be left with a. Because it's to, if you're saying um y squared equals 2. Okay, if you're saying y equals to root let's say 1 over 2, and then you want to know, like, yeah, let's say 1 over 2x, and then you want to know what y actually is, not the root, you'll just square this square is going to cancel this. But what this square really is, it's just root a multiplied by root a, because remember, a square is just when you multiply that thing times 2, right? When you multiply that thing by itself times 2, right? So root times root, they will cancel one another and you'll just have an a. These two figures, they're not going to multiply. Similarly here, we have a root 3 multiplied by root 3. These roots, they're going to cancel one another and we're just going to have a ferry. This only happens, guys. Let me see. Okay, never mind. Sorry. Then we'll have an equals to, and you'll have negative 2, because you said 1 times 2, divided by 3. This will be your answer. Do you understand why it's just a standalone 3 from this 2? Hey guys, do you guys get it? Lisa, do you get it?
Yes, ma'am.
Okay, does everybody else get it?
Yes, ma'am.
Okay. Okay, so now it's like currently now 8. It's like 4 minutes to 8. So I think our class, it will end here. So wait, guys, you guys are telling me in class currently you guys are doing trig, right? That's what you guys are currently doing.
We finished trig a while back. Now we're doing exponents.
You're starting exponents. Okay, so have you guys, the other people, have you guys done exponents yet?
Yes, ma'am.
Okay, I guess in
Yes,
our
ma'am.
next, because for grade 11, for term 1, for your exam, and not for your exam but for your March, which is the one that we are heading to right now, you write trig, exponency, and what else is that other one? Is it functions? Have we done functions together? I don't
Do
know.
you mean this
But yeah,
year?
no, this year, you and I, like in class. I don't remember doing, I don't know. But yeah,
Mm-mm,
if
I
you
don't
guys are
think
doing,
so.
okay, no problem. We'll see which topic we can tackle. Yeah, I'll send or rather than me sending papers, you guys look for papers and then send them to me and then I'll answer them. Nah?
Yes, ma'am.
Okay. Thank you. Thank you for attending. Bye. Shut.